Process control block PCB. A process control block, also called as a task control block, is a data structure maintained by the operating system for every processor. So a process control block or a task control block is a data structure maintained by the operating system for every processor. So it is a data structure maintained by the OS for every processor. The PCB is identified by an integer process ID, PID. So what is PID? PID is a integer process ID. A PCB keeps all informations needed to keep track of a process as listed below in the table. So a PCB has all the informations of a process to keep track on the processor. Therefore, the OS gives every process this PCB. Why is every process given the PCB? So that a track is kept on the information such as process ID, process state, process program counter, priority, CPU register, memory pointers, IO state information and accounting information. So what does a PCB do? It lists all the information needed to keep a track on the process. Therefore, the operating system provides every process with this PCB. So what is a process state? The current state of the process, that is whether it is in the new state, that is whether the process is being created, or whether it is in the ready state so that the CPU takes the process, and or it is in the running state, that is whether the process is getting executed, and so on. Process privileges. This is required to allow or disallow access to the system resources. Process ID, unique identification for each of the process in the operating system. So what is a process ID? It is a unique identification for each of the process in the operating system. Pointer, a pointer to the parent processor. So what is a pointer? A pointer is a pointer to the parent processor. Program counter is a pointer to address to the next instructions to be executed for this processor. So program counter will give a pointer to the address of the next instruction which has to be executed. CPU registers. The registers vary in number and type depending on the computer architecture. They include accumulators, stack pointers, and GPO plus any condition code information. The state information must be saved when an interrupt occurs to allow the process to continue afterwards. So what is an interrupt? Interrupt means suppose there is a IO request sent. So there is an interrupt in the process. So we say that this is IO request is nothing but a interrupter. And once you get the request fulfilled, once the user inputs the numbers, once the request is fulfilled, what will happen? It has to allow the process to continue afterwards. CPU scheduling information. Process priority and other scheduling information which is required to schedule the process. So what is CPU scheduling? CPU scheduling means which process should be allowed to enter the CPU, which process is given the maximum priority to enter inside the CPU is called CPU scheduling information. Memory management information. This includes the information of a page table, memory limits, segment table depending on the memory used by the operating system. Accounting information. This includes the amount of CPU used for the process execution, time limits, job or process number, etc. And IO status information. This includes a list of IO devices allocated to the processor. So it includes a list of input output devices which are allocated to the processor. Structure of a process image in virtual memory. So there is a process identification, process state information, process control information, user stack, then private user, shared address for process 1 also, for process 2 also, like for n processes. And process control block comprises of process identification, process state information, process control information. So it has everything as far as the every information as far as the process is concerned. Who has PCB? PCB has every information as far as the process is concerned. So of the processor.